What's up, guys? Today we're going to be learning about linear equations. Firstly, what is a linear equation? A linear equation is an equation of the form. Well, what's an equation? An equation is anything using an equal sign, basically, saying that what does the equal sign do? It says two amounts on either side of it are equal, right? So we can say 5 equals 2 plus 3. It's true, 2 plus 3 is 5. So that's what the equal sign is used for. So now we have to understand, if we want to understand linear equations, what's a variable? A variable, usually denoted by x, yes, we know it looks a little bit like a multiplication sign, but it's usually used as x, and x can be any value. Basically, we don't know what x is. So say we put x into an equation, x equals 5. Well, now we know what x is 5. But say we have something like, x minus 5 equals, I don't know, let's say 12. Now how do we solve this? Well, first, you need to understand this concept. Let's go back to our 5 equals 2 plus 3 example. So 5 equals 2 plus 3. An interesting thing you can do here is you can add the same amount to both sides. Let's add 6. Plus 6 plus 6. Now what happens here is because we added the same amount to both sides, 6, it's still equal. So let's see if this is true. So we're going to put our imply sign here. Our imply sign, we put it in front of every new equation. It implies 11, because 5 plus 6 is 11, equals 2 plus 3 plus 6, it's 11. Okay? So we basically understand we can add the same thing to either side of an equation, and it'll still be true. This also works with subtraction, as we'll get into later. So first, let's see here. X minus 5 equals 12. How can we get rid of this x minus 5, of this minus 5? Because once we get rid of the minus 5, the x is going to be all by itself, and whatever's on the other side is what x is equal to. So we can do this by adding 5 to both sides. So x minus 5, always write what you had first. So also put in your imply sign. So x minus 5 basically equals 12. Oh, my bad. X minus 5. So then what do? We add 5 to the same side. Plus 5 equals 12. We wrote what we had already. Then what do? We add 5. We added 5 to this side. To keep it equal, we have to add 5 to this side. Right? So this implies, so x minus 5 plus 5. What's minus 5 plus 5? It's 0. So x equals 12 plus 5 is 17. So here we find that x equals 17. But going back, what if we had something like x plus 5 equals 17? Well, now what? As I told you earlier, that same principle holds for subtraction. So we can do the same thing, except we subtract 5 from both sides. So x plus 5, writing down what we had already, and our implied sign, don't forget those. X plus 5 equals 12. Oop, I did that thing again. We got to do the x plus 5 minus 5, right? Because that will get rid of our plus 5. So 5 minus 5, that's 0. So that's how we know it's getting rid of it. Equals 12. Then we subtracted 5 from this side. We got to subtract 5 from this side. Minus 5. Which implies these two will cancel out. We can just cross those out. X equals 12 minus 5 is 7. Right? So again, we figured out x. And that is how you solve very simple linear equations. But what if we get something like this? 2x plus 5 equals 21. Well, firstly, what does 2x mean? 2x simply means 2 times x. Now, I understand that this can get confusing. Now it looks like xx, which doesn't make sense. So in mathematics, when you're using a variable like x, instead of writing the multiplication sign, we just use the dot. Another thing you have to understand here is we don't have to use x. We can use anything we want to. We could use tiny people, like that, smiley faces. We could use the letter T, like that. It doesn't matter. The principle is still the same. It's some kind of symbol that we don't know the value of. So, knowing that this is 2x, or 2 times x, how do we solve this? Well, first, let's apply what we've learned already. We can subtract 5 from both sides. And then what do we have? We have 2x. We normally don't write the symbol of... We normally don't write the equation where you subtract 5. You just subtract the 5, like in your head, and then you write down the answer. Equals, what's 21 minus 5? 16. So 2x equals 16. Can you guys, think of how you might solve this? Well, another cool thing about linear equations, and equations in general, is you can divide both sides by the same thing, divide or multiply, by the same thing and both sides, and it'll still remain equal. So, if we divide x by 2, what do we get? 2x divided by 2 equals 16 divided by 2. So, 2x divided by 2 is basically equal to, I'll put our implied signs in. So, 2x by 2 basically equals x. If you don't know how division works, I'll make a video on that in the future. So, x basically equals 16 divided by 2 is 8. So now we find x equals 8. So yeah, that's basically linear equations. But wait, why are they called linear? So, if we draw a graph like this, in case you don't know what a graph is, I might make a video on that later too. So, this is a graph. And what we do is we mark on our numbers. 1, 2, 3, 4, 5, 6, 7. Okay? 1, 2, 3, 4, 5. We'll put 5 on that side, 7 on that side. Mark it up. Now, in case you don't know, this is the origin. It's 0, 0. This is the x-axis, and this is the y-axis, right? So, what was our linear equation? Basically, let's write 5x plus 10 equals 25. Solving for this, first, what do? We subtract the 10. 5x equals 25 minus 10, 15. Now what do? We have to divide both sides by 5. Because you remember that we'll get rid of the 5. So cut the 5 out of there. X equals 15 divided by 5 is 3. Okay? So now we know that x equals 3. So if x equals 3, then it, in this equation, will graph when x equals 3. So 1, 2, 3. X equals 3 here. But what does y equal? Well, that's the thing. Y can equal anything now, because we didn't really specify that. So if we were to graph this, it would be a line. Straight up and down, going through the 3. and it would go on infinitely because y doesn't have any parameters or limitations. And you'll notice this is a very straight line. Now linear, it actually means line, so that's why it's called linear equations. But say we don't want a very straight line like this, straight up and down. Well, how can we get like a different line, maybe slanting that way? Well, in linear equations, we can actually introduce more variables than one. So if you were to like just do one variable, it wouldn't be really a linear variable. It would only be able to be a line in one direction. Like it would be a linear equation. It would just be a line in one dimension, which is just up and down. So if we want to get 2 dimensions, we add 2 variables, an x and a y. So then, normally equations are written in the form, like, let's say y equals, I don't know, 3x plus 5. So if y equals 3x plus 5, we can't really solve for x. You can try as hard as you want, but you will never find the exact value of x. But what if we substitute in value for x? What if we just assume x equals 0? Well, if x equals 0, 0 times 3 is 0. So y would equal 5. So when x equals 0, we can write down, we can go up 5, 1, 2, 3, 4, 5, and y equals 5. So x equals 0 and y equals 5. Now let's find another point. Let's see what happens when x equals 1. When x equals 1, then 3 times 1 is 3, plus 5, 8. So when x is 1, y is 8. So when x is 1, we go up 8. 1, 2, 3, 4, 6, 7, 8. All the way up there. With 2 points, we can now graph this line. This line is something like that, and it goes on infinitely in both directions. So that's pretty cool. Now we know why linear equations are called linear equation. Because this linear equation makes a straight line. So how do we normally write linear equations? We normally write equations in the form y equals mx plus b. Now it's really confusing. What do all of these mean? Well, y is the y coordinate, x is the x coordinate, but what are m and b? Well, here, m and b aren't actually unknown. We know the value of m and b, but this is a generic equation that we are using like as if, like, we don't know m and b. M and b can really be anything. But what do they stand for? M is the slope. In case you don't know, slope is rise over run. What does that mean? Rise is how much you increase in the y-axis. So say from this point to say this point. So this point is what? 0, 1, 2, 3, 4, 5. It's 0, 5. And this looks like minus 2, 1, 2, minus 2.5, 0. Right, so we got minus 2.5, 0 here. So, a rise over run, our rise here is the first y. We'll say this one is the first y. So here 5 is the first y. 5 minus your second y, which here is 0, divided by your run, how much it increases in the x direction, which is basically your first x, which here is 0, minus your second x. Here it gets a little tricky. Your second x is actually negative 2.5, which, if you know how this kind of subtraction works, you'll know it's actually 0 plus 2.5, which equals 5 by 2.5. If you know how fractions work, then you know you can write this as 10 divided by 5, which equals 2. So that's our slope. it means for every 2 we go up, we go that way 1. We go up 2, go that way 1. Go up 2, go that way 1. And you'll see we can find every point on the line this way. So that's what M is. But what's B? B, basically, you see it intersects with the y coordinate here. B is basically how far up that is. So 1, 2, 3, 4, 5. B here is basically 5. So here, y equals 2x plus 5. Okay, now you'll notice something. When I originally graphed this line, I'm pretty sure I wrote the equation y equals 3x plus 5, I think. So what basically happened here? It's the same line, so I should get the same equation, right? Well, I probably just drew this wrong, so that's why that's happening, if you're wondering about that. So yeah, that's linear equations. If you have any questions, please let me know in the comments, and I will try to answer them for you. And if you have any suggestions for my videos, again, leave them in the comments. If you like the video, please like and subscribe, and we'll see you in the next one. Thanks.